Okay, so hi everyone, welcome to the class. Okay, so before we start our class, okay, so let's we do some recap on what we already learned yesterday. Okay, so yesterday we already learned about uh wait, okay, so today we already learned about how to calculate the probability for independent and dependent event. Okay, so we learn about independent event. Okay, so where the event in the prior event will not influence the result in the next event. Okay, so previous event will not influence result of the next event. So that is what we call as independent event. Okay, sorry. Okay, all right. So that is independent event. Okay, and then we learn about dependent event where your result, okay, in the first event, okay, will influence the result of the next event. Okay, so result event A will influence the result in the event B. So that is what we learn. Okay, so we learn through the example here. Okay, where we have 10 ball in the urn with a different color and different tag. Okay, and then we also learn about Bayes theorem, how we can simplify our calculation using the Bayes theorem. Okay, so using the Bayes theorem, we just replace the historical data into the formula. Okay, and then we also add on the new information that we have. Okay, and then we can get the probability for the new probability for the event. Okay, so these are the formula that we can use. Okay, this is the Bayes theorem formula. Okay, all right, so we already covered that one. Okay, and we also learned that to improve the probability value of your to improve the accuracy of your probability calculation, we try to repeat the test. Okay, we repeat the experiment so we can get better result. Okay, all right. Okay, and then lastly, before we end our class yesterday, we learn about what is random variable. So we have two type of random variable. First is discrete. Okay, and then another one is continuous. Okay, so it is important to understand why it is important to understand uh why it is important to understand type of variables. Okay, because we will learn today about the distribution. Okay, so in order for you to understand the probability distribution of your variable, you have to know what type of variable you have. Either it is discrete or it is continuous. Okay, so today we will learn about probability distribution. Okay, so why probability distribution is important? Because, okay, for example, okay, based on your calculation, you can plot your probability value. Okay, and then from the probability value, okay, from the probability graph, okay, you can see the trend. Okay, all right. Why? Okay, so from the trend, you can know. Okay, if let's say you want more than 50% chances, what is the value of your variable? Okay, if let's say you want 80% chances, okay, what is the value of your variable? Okay, so this is where, okay, this is the importance of probability distribution. Okay, because based on the distribution, we can see, let's say, if with 50% 50% confidence. Okay, is that, okay, we are confident, okay, 50 in okay 50% confident, what is the value of our variable. Okay, and then if let's say you want you want to increase your confidence level. Okay, maybe 80% confirm. Okay, so you go for you look at your distribution. Okay, then you see, okay, if your distribution is 80% and above, what is the value? Okay, so 80% and 90% confident. Okay, most of the time we will use 80 to 90% confident. Okay, means that we are really sure that we can get this value. Okay, so this is where you need the probability distribution. You have to understand how to construct the probability distribution graph. Okay. All right. So for discrete random variable, probability value assigned to each event. Okay. So every event, every variable value, they will have their own probability value. Okay. Example here. Okay. You have 100 students in one class. Okay, and then you do a quiz with 5 problems. Okay, you give the student five questions. Okay, with the question, okay, with 1 point for each correct answer. Means that if the student answer one correct question, they will get one question. They will get 1 point. Okay, so the result of the student can vary from 1 to 5 or 0 to 5. Maybe they are not they okay. So if the student cannot answer correctly all the question, they will get 0 mark. Okay, one question correct, one mark. Okay, until 5 question until all question are correct, then they will get 5 marks. Okay, all right. Okay, so these are the example. Okay, so this example followed 3 rules. Events are mutually exclusive and collectively exhaustive. Individual probability value between 0 and 1. Okay. Total probability sum to 1. Okay, so you can see here now the rule number 2 and number 3 actually is the rule of probability. Okay, so your probability must be between 0 and 1, and the total of your probability must be equal to 1. Okay, so these are the basic probability rules that you have to follow. Okay, and then they just add on another rules. The event is mutually exclusive, and then it is collectively exhaustive. Why is mutually exclusive? Because there is no chances that the student can get 1 and 2 marks. Okay, means that if after the student answer the question, their mark can be only one value, either 1, 2, 3, 4, or 5. They cannot be 1 and 2. Okay, the student mark is 1 and 2, cannot. Okay, so this one is mutually exclusive event. Okay, and then this event also collectively exhaustive because you consider all the outcome you can get from the event, which is 0 marks, 1 marks, 2 marks, 3 marks, or 4 marks. Okay. All right. Okay. So these are the questions. So based on 100 students, okay, they already plot. Okay, they already tabulated the number of students that gets 1 mark, number of students that gets 2 marks, number of students that gets 3 marks, number of students that gets 4 marks, and number of students that get 5 marks. Okay, so based on the number of students, the number of students that gets corresponding marks, then you can calculate their probability. Okay, so for example, 10 students score full marks, which is 5 marks. So the probability of student getting full mark is 10 over 100 student, because we have total of 100 student. Okay, so to calculate the probability is 10 student out of 100 student, which is 0.1 or 10%. Okay, it means that in the class 10% of the student get 5 marks. Okay, and then for the student who score 4 marks, there are 20 students that score 4 marks. The of student getting 4 marks is 20 students out of 100 students, which is 20%. Okay, so 20% of the students are getting 4 marks. Okay. And student 30 out of 100 or 30%. Okay, so for 2 mark is 30 student also, so 30 over 100 is 30%. And then lastly, 10 student only score 1 mark, so the probability of the student get 10 mark 1 mark is 10 out of 100 student, which is 10%. Okay, so this is how you develop. Okay, so this is how you calculate the probability for each mark. Okay, it means that 10% of the student has chances to score 5 marks, okay, full mark. 20% of the student, okay, will score 4 marks. 30% of the student will score 3 marks. Okay, 30% of the student will score 20 marks, and then lastly, 10% of the student will score 1 mark. Okay. Alright, and then develop using relative frequency approach. Okay, and then you develop the distribution. So this is what we call as distribution. Okay, so here you put it in the graph. Okay, so instead of putting number of students here who score the mark, okay, here we put as probability. Okay, probability that we already calculated. So for 1 mark, okay, for 1 mark, okay, for student scoring only 1 mark, there is 1 chances. Scoring 2 marks, okay, the probability is 0.3. Scoring 3 mark, the probability is 0.3. Scoring 4 mark, the probability is 0.2, and then lastly, scoring full mark is 0.1. Okay. Alright, so this is how you create the probability distribution graph. Okay, and then central tendency of the distribution is the mean of or expected value. Amount of variability is the variance. Okay, so from this graph we can calculate what is the average what is the average score that the student will have. Okay, and then we also can calculate the variance. Okay, means that what is the gap. Okay, the gap between the apa kita panggil dia apa ni, daripada purata ni, nilai purata markah tadi, kita nak tengok berapa besar jurang daripada yang rendah kepada yang kecil, yang besar pada yang kecil. Kita nak tengok gap dia. Okey, jadi gap ni kita kira dia mana dia kawasan yang tengah-tengah. Okay, jadi kat mana sebenarnya markah
sorry, sir.
Sorry?
Can you speak English, because I'm not really good in
Okay. Sorry. Alright, okay, no problem. Alright, so we want to the gap between the highest and the lowest mark that student can achieve. Okay, So variance. Okay, so from the probability graph, we can calculate the mean. Okay, the mean of the mean marks. Okay, the average. Okay, the average mark the student can score, and then their variance. Okay, all right. So expected value is the measure of central tendency of the distribution. Okay, so we can use this formula. Okay, so we can calculate the expected value or the central tendency. Okay, means that the central the marks in the middle. Okay, means that we have so many. Okay, we have marks from 1, 2, 3, 4, and 5, right? We want to based on the distribution of the mark. Okay, among 100 students, we want to see where is the central value, the central value. Okay, so to know the central value, we can use this formula. Okay, so the expected value of x is the summation of xi multiplied by probability of xi. Okay, so what is xi? Xi is the mark. Okay, here in this example, xi is the mark here. So x1 is x1 is 1, x2 is 2, x3 is 3, x4 is 4, x5 is 5. Okay, so xi is the x value here. Okay, so x value here. So this one is x1, this one is x2, this one is x3, this one is x4, this one is x5. Okay, and then we multiply it with the probability of xi. Okay, so means that you calculate. Okay, so 1 multiplied by 0.1. Okay, plus 2 multiplied by 0.3, plus 3 multiplied by 0.3, plus 4 multiplied by 0.2, I think 0.2. Okay, and then plus 5 multiplied by 0.1. Then you will get the expected value of x. Okay, so these are the 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 expected value for this example. Okay, so expected value of x, the expected value of the mark is 5 multiplied by 0.1 plus 4 multiplied by 0.2 plus 3 multiplied by 0.3 plus 2 multiplied by 0.3 and then plus 1 multiplied by 0.1. Okay, so if we calculate this value, okay, so we do the multiplication first. So here will become 0.5 plus 0.8 plus 0.9 plus 0.6 plus 0.1. Okay, then you will get 2.9. So 2.9 is the average values. This is the central tendency or the average value. Okay, so these are the mean, the average value of score, the student score. Okay, so based on your quiz you done for 100 students. Okay, you can say that the average score for 100 students is 2.9 marks. Okay, so the average score for the student is 2.9 marks. Okay, and then how to calculate the variance? Okay, we want to know the variance of the marks. Okay, so to calculate the variance of the mark is to sum of xi minus mean of x, ex, to the power of 2 multiplied by probability of xi. Okay, so these are the formula. Okay, right. So this is how you do it. Okay, so xi, so 5. Okay, x1 is 5 minus ex is 2.9 to the power of 2 multiplied by 0.1. Okay, and then plus x2, which is 4 minus 2.9 to the power of 2 multiplied by probability of x2 0.2. Okay, and then plus 3 minus 2.9 to the power of 2 multiplied by probability of x3 0.3. Okay, and then you go on until x5. Okay, so because we have 5 variant, okay, sorry, we have 5 variable, right? So we have to do until variable 5. Okay, so now you have to do the deduction first. Okay, then you get 2.1 to power of 2 multiplied by 0.1 plus 1.1 to the power of 2 multiplied by 0.2 plus 0.1 to power of the 2 to the power of 2 multiplied by 0.3 plus negative 0.9 to the power of 2 multiplied by 0.3 plus negative 1.9 to the power of 2 multiplied by 0.1. Okay, so then you calculate all these things, you will get 1.29. So these are the variance. Means that from 2.9, okay, so the 2.9 is the average, right? The mean. Okay, so the gap, okay, the 50% of the student will score between 2.9 minus 1.29 and 2.9 plus 1.29. So that is where the central distribution of the mark is. Okay, so these are the usage of variance. Okay, we want to know the lowest and the highest number, okay, for the 50% distribution of your variable. Okay, all right. And then, okay, so that is variant. Okay, so variant you have to remember, variant is to the power of 2. Okay, so to get the standard deviation, you have to square root the variant. Okay, so once you square root the variant, okay, you will get, okay, so the square root of the variant is square root of 1.29, you will get 1.14. Okay, so variant is much larger. Okay, and then when you get standard deviation, you are looking for a smaller window. Okay, so now instead of 50%, you're looking at, if I'm not mistaken, is 30% in the center, if I'm not mistaken. I forgot the distribution. Okay, but variant and standard deviation actually similar, because we want to know the gap, okay, of your central distribution. Okay, so we get the mean value, and then we get the variant and standard deviation value to know the central distribution of your variable. Okay, all right. So that is the usage of mean, variant, and standard deviation. Okay, so this one is if you are using the Excel. Okay, so using the Excel, you also can calculate. Okay, so this one actually is the okay, so this one actually they are using the normal calculation. So you just input the formula here. So this one is equal to B2 multiplied by A5. Then you get here the value of in C. Okay, and then here is the value of, okay, so how to calculate in D? So D is equal to 5, okay, sorry, equal to in bracket, equal to you using the function power. Okay, so power, okay, so power, the number here, the number is A2 minus C2, okay, and then comma, the power is 2, okay, and then close bracket, multiply by B2. Then you will get here the value here. Okay, and then at the bottom you just sum. Okay, so this one is equal to sum C2 until C6. Okay, then you will get the value here. Okay, so this is how you calculate the mean, variance, and standard deviation using Excel. Okay. All right. Okay. So here they show you how they how they do the the calculation. Okay. So this is the formula. All right. Okay. So that is discrete distribution. Okay. So that is discrete distribution. Okay. So you can see here discrete distribution. Okay. So is discrete distribution is a bar graph. Okay. Here, so here we have 1, 2, 3, 4, 5 like that. Okay. So these are discrete. Okay, because they are not continuing to the next variable. Okay. So this one, you see from 1 and 2 you have gap here. 2 and 3 we have gap here. 3 and 4 we have gap here. 4 and 5 we have gap here. Okay. So if you see probability distribution graph like this, automatically this is the discrete distribution. Okay, so these are what we call as discrete probability distribution graph. Okay, all right. Okay, so what if you have continuous variable? How about if you have continuous variable? Okay, so to develop the probability distribution for continuous variable, the fundamental rule for continuous random variable must be modified. Okay, so we have to make some changes from what we already looked at the discrete one. So now in continuous variable, we have to make some changes. Okay, so how to do it? What is the rule we have to change? The first rule is sum of probability value must equal 1. Okay, similar. The probability of each individual value of the random variable occurring must equal 0, or the sum would be infinitely large. Okay, so these are the two rules we will use when we want to develop probability distribution graph. Okay, sorry. When we want to develop continuous variable probability distribution graph. Okay, so the probability distribution is defined by continuous mathematical function called probability density function, or just the probability function represented by fx. Okay, so different from discrete variable where we can get the probability probability value for each variable, then we can plot it. Okay, for continuous variable graph, we cannot do like that. Okay, we have to develop what we call as probability function fx. So we have to develop probability function x first. So this is how we will design the graph. Okay. All right. So these are one example how probability distribution continuous probability distribution graph look like. Okay, so if you still remember, for discrete you have 1 bar, 2 bar, 3 bar like that, and then the bar is not connected, right? There is a gap between each bar. Okay, but for continuous distribution, we cannot do that because the number is, like I said before, the number will be between you will have result between each variable. For example, here you put here the variable is 5.06, right? You will have result 5.08. You will have 5.09. You can also have 5.065 here. Okay, so you cannot plot it only in a discrete manner. Okay, so you have to plot it in the line. Okay, like this one. So this one is a line graph. Okay, so you have to plot it in a line graph. Okay, all right. Okay, so but the graph is still similar. You plot probability versus the variable. Okay, the graph is still similar. Probability versus variable. But how you plot the graph will be different. Okay. So this line will follow what we call as probability function fx. Okay. So f in bracket x. Okay. So we have to develop the function of x to plot this graph. Okay. So this one is one of the example of continuous distribution graph. Okay. All right. For any continuous distribution, the probability does not change if a single point is added to the range of the value that is being considered. Okay. For example, the following probability are all exactly the same. Okay. You want to check the probability of 5.22. Okay, from 5.22 until 5.226. Okay, so this one is similar with probability of looking for between, okay, probability of value x between 5.22, okay, bigger than 5.22, lower than 5, okay, lower or equal to 5.26. Or you can also, it is also similar with probability of x value equal to or less than okay, sorry, probability of x value equal to or larger than 5.22 or smaller than 5.26. And then this one also similar with probability of x value between 5.22 and 5.26. Okay, so this one, okay, for continuous variable distribution, these four what we call it, this four probability is similar. Okay, you will get similar value. If you are writing the probability like this, okay, so it means that you want to know probability of x value will bigger than 5.22, okay, but less than 5.26. Is similar if you are looking for probability of x is equal or larger than 5.22 and smaller or equal to 5.26. Okay, so this one is similar. Okay, you can write it. Okay, for continuous random variable, you can write it in any manner. You can write it either like this, either like this, or like this. You will still get similar value of probability. Okay, so these are what we call as continuous distribution. Okay, so continuous probability distribution graph. Okay, all right. So to develop this one, you have to know the function of your probability function of x. Okay, the probability function of x. You have to know that so that you can plot this one. Then from there you can check the value. Okay, you can check the probability value. Okay, right. Okay, so that is continuous variable distribution. Okay, and then we have what we call as binomial distribution. Okay, so many business experiment can be characterized by Bernoulli process. Bernoulli process is described by the binomial probability distribution. Okay, so binomial distribution is the most common one used in business world. Okay, so what is binomial distribution? Okay, so binomial distribution, you can get it from a process, we call it as Bernoulli process. So what is Bernoulli process? So in Bernoulli process, each trial has only two possible outcomes. Okay, so when you want to do when you want to use the binomial distribution, the outcome can only be two. Okay, for example, maybe success or failure, or maybe if let's say you are talking about machine, either it is in good condition or broken. Okay, and then maybe if we are talking about customer. Okay, either they are buying or they are not buying. Okay, so they are all they okay to plot the binomial distribution, the result must be either the result must be only you can to plot the binomial distribution. Okay, the result of the event can only be two outcome, either A or B. Okay, so the first one, the outcome must be only two. Okay, and then the probability for each outcome stay the same from one trial to the next. Okay, it means that the event must be mutually exclusive. If you repeat, the process, the probability will be the same. There are no changing to the probability. Okay, and then the trial are statistically independent. Okay, and then the number of trial is a positive integer. Okay, means that the number of repeat, the number you repeat. Okay, how many times you repeat must be positive. Okay, it cannot be negative. Means that you cannot have a number of trial is negative 2. Okay, it's not logic. Okay, okay. So the number of trial here must be positive integer. It means that from 1 until infinity. So 1, 2, 3, 4, 100, 200, 1,000,000, and etc. Okay, must be positive integer. Okay, so this is what we call as Bernoulli process. Okay, and then from the Bernoulli process, we can develop what we call as binomial distribution. Okay, so what is binomial distribution? So binomial distribution is used to find the probability of a specific number of success in a number of trial. Okay, so we have an experiment. So we want to know what is the probability or the percentage of chances we can succeed the experiment. Okay, so these are the common usage of binomial distribution. We want to know what is the percentage, what is the chances that we can succeed, we can get what we want from the trial. Okay, so to plot the binomial distribution, we need to know how many trial you will do. Okay, how many times you will repeat your experiment. Okay, and then you also must know the probability of success on any single trial. So you have to know what is the chances you can succeed, okay, in one experiment. What is the probability that when you run the experiment you will get a successful result. Okay, so you have to know the probability value of getting successful result. Okay, so we need to have these two numbers. Okay, when we want to do the binomial distribution. Okay, and then we let R is the number of success, Q is 1 minus P, or the probability of failure. Okay, so once we know how many trial we do, okay, and then what is the probability we can success in one trial, then we can calculate how many successful experiment we will have. And then we can also calculate what is the chances our experiment will fail. We just deduct 1, okay, minus probability of success. Okay, then we will get the value of failure. Okay, the probability value of failure experiment. Okay, Okay, so these are the formula that we use to calculate. Okay, the probability of R success in n trial is equal to n factorial divided by R factorial multiplied by n minus R factorial multiplied by P to the power of R multiplied by Q to the power of n minus R. Okay, so these are the formula. Okay, so these are the formula we will use, okay, to calculate the probability of our success. Okay, we want to calculate the probability of getting success. Okay, we want to calculate the number of successful experiment from a number of trial. Okay, so we want to know this is how we calculate the R value. Okay, so this is how we calculate the R value. Okay, from this we can calculate R value. So symbol exclamation mark means factorial. Okay, so it means that if let's say we have n factorial is equal to n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 until 1. Okay, for example here, if you are looking, okay, for example, if you have 4 factorial, it means that 4 n value multiplied by n minus 1, which is 4 minus 1, you get 3, and then multiply by n minus 2, so 4 minus 2, 4 minus 2 is equal to 2, okay, and then n minus 3, so 4 minus 3 is 1, so you get 1 here, okay, so you end it until you get 1, okay, so you multiply all this, 4 multiplied by 3, 12, 12 multiplied by 2 is 24, 24 multiplied by 1 is 24, then you get 24. Okay, so if you have 1 factorial, the number is 1, and then if you have 0 factorial, it will become 0. Okay, so this one is how you calculate how you want to calculate the probability of success. Okay, given you have multiple number of trial. For example, find the probability of getting 4 head in 5 toes of a coin. Okay, so it means that you have 5 trial. Okay, you have 5 trial. You want to know what is the probability of you getting 4 head if you throw the coin 5 times. Okay, so the number of throw is 5, so n is equal to 5. So n is the number of trial, right? So the number of try is 5, so because you throw 5 times. Okay, so n is 5. Okay, and then the number of success R. So number of success is 4. Okay, because you want to get 4 heads. Okay, so the number of success is 4. So R is equal to 4. What is the probability of getting head? Okay, so for a normal coin, the probability of getting head is 1 out of 2 outcome. Okay, so it means that the probability value is 0.5. So P is 0.5. Okay, so once you get the P value 0.5, then you can calculate the value of Q, the probability of getting tail. So the probability of getting tail is 1 minus 0.5, then you will get 0.5. Okay, right, so to calculate what is the probability of getting 4 head out of 5 throw. Okay, 5 coin toss, sorry, not throw, 5 coin toss. Okay, so you use the formula. So n factorial divided by r factorial multiplied by n minus r factorial, okay, multiplied by p to the power of r multiplied by q to the power of n minus r. Okay, so 5 factorial is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay, divided by 4 factorial, 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay, and then 5 minus 4 is 1. So 1 factorial is 1. Okay, so again here, so 1 factorial, the value is 1. So just put here 1. Okay, and then multiply by 0.5 to the power of r, to the power r is 4. So 0.5 to the power of 4, you will get 0.0625. Okay, and then multiply with q, which is 0.5 to the power of n minus r. So n is 5 minus r is 4. So 5 minus 4 is 1. So 0.5 to the power of 1 is 0.5. Okay, so this is how you calculate. So use, okay, so then you solve for the, you solve the equation, then you will get 0.15625. Okay, only or 15.625% chances you can get 4 heads out of 5 coin. Okay, so only 15% chances you can get 4 head out of 5 coin toss. Okay, 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 so this one is how you, okay, so this one, you want to plot the binomial distribution. Okay, so you want to plot the binomial distribution, right? So now, out of 5 row, how many times you will get head? Either is 0, is 1 head, 2 head, 3 heads, 4 heads, or 5 heads. So how to calculate the probability? We are using this, you are using this formula. Okay, so using this formula, you can calculate the probability. Okay, so here is the probability. So for if you for getting 0 head, it is 0.03125. Getting 1 head is 0.15625. Getting 2 head is 0.3125. And then getting 3 head is 0.3125. And then getting 4 heads is 0.15625. And then getting 5 heads is 0.0312125. Okay, so from this calculation, you can plot the binomial distribution. Okay, so the binomial distribution, okay, is this almost similar like how discrete probability distribution graph looks like. Okay, so we can, okay, so it is similar. Okay, so we just plot the probability of x versus x value. Okay, so this one here, I think this one is wrong. So it's supposed to be 0, 1, 2, 3, 4, and 5. Okay, so binomial distribution is similar with discrete distribution. Okay, how you plot the distribution is similar. Okay, the graph looks alike lah. Okay, the graph will looks alike. Okay, just the difference is how you calculate the probability. Okay, for binomial, you can use the formula given. Okay, so you can use this formula to calculate the, okay, so you can use this formula to calculate the probability value. Okay, all right. Okay, so this one is example. So how you want to solve problem with binomial table? Okay, these are examples. So MSA Electronic is experimenting with manufacture of new transistor. Every hour, a random sample of 5 transistors is taken. Probability of one transistor being defective is 0.15. Okay, so what is the probability of finding 3, 4, or 5 defective? Okay, so the question asks, okay, out of 5 transistors you take, what is the chances that you will find 3 out of 5 transistors is defect? Okay, second one is, what is chances you will find 4 out of 5 transistor is defect? Okay, and then lastly, okay, the last event is, what is the chances that you will find all 5 transistor is defect? Okay, so we want to know the probability of finding 3, 4, or 5 transistor defect from the sample. Okay, so from there you can develop the probability distribution. Okay, right, so here, okay, all right, so this is how you use the table. Okay, so this one, we call it as binomial distribution table. Okay, so in this table they will specify the number of trial, the number of success, okay, and then the probability value. Okay, for example here, because now because we only have 5 samples, so means that 5 try, so the n value here will be 5. Okay, and then we want to look for the r value 3, 4, and 5. Okay, so look at the r value 3, 4, and 5. Okay, and then the probability value for the trial is 0.115. Okay, so here the probability value here highlighted in the blue highlight here. This is the probability value of finding three transistor defect. Okay, the bottom, okay, and then below it, okay, this is the probability of finding four defect transistor. Okay, and then this is lastly, this is the probability of finding all transistor defect. Okay, so you can use the binomial distribution table to directly calculate getting the value of probability. Okay, so instead of doing the calculation, you can just take the value here and put it in the graph. Okay, so what is the, okay, so now we want to know the probability of finding 3 or more defect. So we have here 3, 4, and 5 defect. So what is the probability we will find defect more than 3? So more than 3 means that 3, 4, and 5. Okay, so how to calculate the probability? You just add on the probability of finding 3 defect, the probability of finding 4 defect, and probability of finding all 5 defect. Okay, so you just add on. So 0.0244 plus 0.0022 plus 0.0001. Then you will get the probability of finding 3 or more defect out of 5 sample is 0.0267. Okay, so this is what we call as binomial table. So we can use this table to directly find the value of probability that we want to have. Okay, all right, okay, and then from the probability value here, we can calculate the expected value or mean. Okay, we can calculate the mean value and also the variance value for the sample. Okay, so to find the mean value, you just multiply the number of trial multiplied by the probability of the probability of finding the finding the defect. Okay, and then to calculate the variant, you just have to multiply the number of trial. Okay, multiply by the probability of finding defect, multiply by 1 minus probability of finding defect. Example. Okay, so for the example, okay, what is the mean value of the what is the mean value of finding defect for the transistor? You just have to multiply the number of transistor sample, multiply by the probability of finding defect, which is 0.15. Okay, so 0.15 multiplied by 5 is equal to 0.75. Okay, so the mean value is less than what? It means that it is most likely that you will not find any defect from the transistor, because the mean value is less than 1. Okay, means that it means that you are more likely to find nothing, no transistor being defect. Okay, other than you finding one transistor defect. Okay, so based on the mean value, you can see that most of the time the transistor is all the transistor can pass the quality test. Okay, and then what is the variant of the example? Okay, so you calculate directly. So n multiplied by p multiplied by 1 minus p. Okay, you replace the value. So n is 5 multiplied by p 0.5 multiplied by 1 minus p 0.5. Then you will get 0.85. Okay, so the variance value for this example will be 0.63775. Okay, all right. So this one is if you are using the Excel. Okay, using the Excel, you can use function binomial binomial distribution. Okay, so binomial distribution is the formula when you want to calculate for binomial distribution. If you want to know the probability for binomial distribution graph. Okay, all right. Okay, I think it is too many formula you have to remember. Okay, so we take a 10 minutes break. Okay, before we continue a little bit for normal distribution. Okay, just a little bit. I don't want to go too deep for this one first. Okay, because we have too many formula already in the previous slide. Okay, so let's take a 10 minutes break. Okay, and then we will continue back in 12:10. Okay.
Okay, sir.
Okay, let's we continue our lesson. All right. So we already learned three type of distribution. First is discrete distribution. Second one is continuous distribution. Okay. And then we also learn about binomial distribution. Okay. So the next distribution we have here is what we call as normal distribution. Okay. So normal distribution is one of continuous distribution, continuous probability distribution. Okay. So binomial, okay, the one that we already learned before. Okay. So that one is one type of discrete probability distribution. Okay. And then we have here is normal distribution. So it is one of continuous probability distribution. This is one of continuous probability distribution. Okay. And then it is also the most popular and useful distribution. Okay. The most popular and useful continuous distribution. Okay. So what is normal distribution? So normal distribution, they are characterized by this equation. Okay. So if you still remember, for continuous probability distribution, we have to develop the function of x, the function of the variable, so that we can plot the probability distribution for the variable. Okay. So this is one type of function. Okay, this is one type of probability function x. Okay, so this function is for normal distribution, normal probability distribution. Okay. Okay, so for normal probability distribution, the function of x is 1 divided by what is this? Standard deviation. Okay, standard deviation, 1 divided by standard deviation multiplied by the square root of 2 pi, okay, multiplied by epsilon to the power of minus in bracket x minus mu, mean. Okay, x minus mean, okay, close bracket, to the power of 2 divided by 2 multiplied by standard deviation to the power of 2. Okay, so this is the standard standard function for the normal distribution. Okay, so this is the function for normal distribution. So this is how the function for normal distribution looks like. Okay. All right. Okay, so this figure show you the example of normal distribution. So normal distribution, their graph will look like this. Okay, so their graph will look like an inverted bell. Okay, so these are what you call as inverted bell graph. Okay, inverted bell graph. Okay, so this is how normal distribution looks like. Okay, all right. So this is a normal distribution distribution graph for mean 50. Okay, mean equal to 50. So the value of mean is 50. Okay, so for this one, the value of mean is 40, smaller than the first example. Okay, all right, but the standard deviation is same. Okay, so the shape of the graph will be same, but the position of the graph will be changing. Okay, because the mean, okay, the mean value must be in the middle of the graph. Okay, for normal distribution, the value of the mean value must be in the middle of the graph. Okay, so that's why if you have mean 50, then your graph will be here. Okay, when your mean is 40, then your graph will shift to the left. Okay, because they follow the value of mean. So now, okay, instead of the graph, okay, is in the middle, now you move to shift to the left. Okay, and then similarly, if let's say your mean value is 60, okay, now your graph will be shifted to the right. Okay, right, because like I said before, the mean value must be in the middle of the graph. So the peak, the peak of your graph will be on the on the value of the mean. Okay, all right, that is the effect of mean value to your graph. Okay, so what is the effect of what is the effect of standard deviation value to your graph? Okay, so for standard deviation, it will determine the shape of your bell curve. Okay, if your standard deviation is small, okay, the value of your standard deviation is small, then your bell curve shape will become small and more sharp. Okay, your bell curve graph will become smaller and sharper. Okay, but if you have larger standard deviation value, your bell shaped curve will become broader and less peaker. Okay, so the peak will become, okay, the peak will become more what we call it, the peak will become less obvious compared to smaller standard deviation, and then the bell shape also become more broader. Okay, so this is the effect of standard deviation value and mean value. So mean value only move your graph, okay, according to the value. Okay, but the standard deviation value will determine the shape of your graph. Okay, all right, symmetrical with the midpoint representing mean. Okay, so the graph, okay, the distribution of the normal distribution graph, okay, their peak will be in the mean value. The peak value is your mean value. Okay, means that the peak, okay, your graph, okay, if you have the peak on your graph, the peak must be on the mean value. Okay, and then shifting the mean does not change the shape. Okay, so because the shape is determined by the value of your standard deviation. Okay, so shifting, okay, if your mean value is changing, okay, you only move your graph. Your graph shape will stay the same. Okay, you just move your graph either to the left or to the right. Okay, value on the x-axis measure in number of standard deviation away from the mean. Okay, so the distribution here, okay, so the distribution here, the x value distribution, okay, will be depending on your standard deviation value. Okay, if your standard deviation is larger, then the limit from the lowest to the highest value of x will become higher. Okay, so the standard deviation will determine the gap between the smallest value of x and the largest value of x. Okay, as standard deviation become larger, curve flatten. Okay, if your standard deviation is, okay, the value of your standard deviation is large, then you will have broader shape like this. Okay, so you will not have any peak in your graph. Okay, so your graph become flattened, we call it as flat. Okay, and then if your standard deviation value is smaller, then your curve become steeper. Okay, your curve become more, okay, the peak of your of your graph will become more prominent. Okay, you can see it become smaller and thicker. Okay, all right. So this is the effect of standard deviation. Okay. Right. I think I want to stop until here. Okay, so that you can look back at the video later. I will upload. Okay, to do your revision. Okay. I think I'm afraid that too many information I will giving to you if I'm continuing the class. Okay, so I think we stop until here. Okay, so we continue the lesson in the next class. Okay, so okay, I will give you the video. Okay, sorry, the lecture video later. Okay, I will share with you the YouTube link. Okay, then you can watch it through the YouTube. Okay, or you can download it. Up to you. Okay, so you can do your revision back. Okay, using my lecture video. Okay, all right. So before we end our class, is there any question, guys?
Sir.
No, so far no, sir.
No, sir.
Okay, no question. Okay, all right, so it's okay. Okay, I will prepare some question for you to do some tutorial. Okay, because I want you to understand what I teach you today and also yesterday. Okay, so I will prepare some tutorial question. Okay, for you to do at home. Okay, so I will share it in the group chat later. Okay, so you can use the question. Okay, together with my lecture video to improve your understanding about what we learned these 2 days. Okay, all right. Okay, so if there is no question, I think that's all from me today. Okay, thank you guys for coming. Then we will see again. I think next 2 weeks, right?
Yep, next week.
Yes.
Yes,
Yeah,
sir.
next week, right? Okay, so next week we will see again. Okay, so thank you guys for coming. Enjoy your weekend. Okay, so I see you back in the 3 weeks in the 2 weeks time. Okay, so anything you want to ask me, you can just ask me in the group chat or directly WhatsApp me. Okay, all right. So thank you
Okay, sir.
everyone. Have a nice day and goodbye.
Thank you.
Thank you, sir.
Thanks, sir.
Thank you,
Thank you,
sir.
sir.
Okay.
Thanks,